welcome on stage Tayba Al-Hashemi, Chief Executive Officer, ADNOC Offshore. Jennifer Holmgren, Chairman and CEO, LanzaTech. Jeff Myers, Global Director of Partnership and Alliances for Energy and Utilities Business Unit, AWS. Jennifer Obertino, Senior Vice President, Global Energy Practice Leader, AECOM. Moderator, John Moore, Chief Executive Officer, BloombergNEF.
Thank you for joining us, panel. So I showed some data. It's actually now we're going to get some sort of real-world discussion about what's happening, what are the challenges, what's working well, et cetera. So first off, Jeff, I'm going to come to you first off. And around which of the key technologies are you investing in, and what progress are you seeing? How is that working out?
So appreciate the question, John. It's interesting to kind of see some of the data that you shared because Amazon is participating in many of the technologies that you sort of covered off in that presentation. It's probably worth beginning with just a bit of context around so our from an Amazon perspective, our ambition with respect to becoming net zero. In 2019, we were the co-founder of what's called the Climate Pledge, which is, it's an agreement now actually signed by over 525 companies in 45 countries to become net zero by 2040, so 10 years ahead of the Paris Agreement. So since 2019, we've been working feverishly to achieve that objective. Probably the most mature, I think, of our investments has been in the renewable energy space. In 2024, for the 5th year in a row, Amazon is the largest corporate purchaser of renewable power in the world. So we're very proud of that. And in fact, we had an ambition as a part of that to match 100% of our power needs with renewable energy purchases by 2030. And we actually achieved that objective 7 years ahead of 2030 and 2023. So we're excited about that as well. And in doing so, we participate now in around probably 600 wind and solar projects around the world. So we're excited about the scale that we're able to achieve in that space. So renewable energy for us is probably the most mature. I would say the second area of focus for us is both the decarbonization and electrification of our transportation fleet. Mm-hmm. Actually, when we established the Climate Pledge, we also set up internally something that we call the Climate Pledge Fund, which set aside $2 billion for investment in decarbonization and net zero technologies. One of those investments we made early on was in Rivian, so that we could decarbonize our last mile transportation fleet. We made an equity investment in Rivian and also ordered 100,000 vehicles for package deliveries. As of, I think, last year, we've got around 20,000 or so now operating in the United States, so more to come in that space as well. And we've also, tested some, in our kind of middle mile, long haul transportation. We've also tested hydrogen fuel cells as a form of electrification of that fleet as well. So hydrogen is also an area that we're beginning to see more investment in. As an example, we've begun to convert our forklift fleet in our fulfillment centers and warehouses to run on hydrogen rather than propane. So we're becoming a consumer now of hydrogen as well. You mentioned CCUS in your presentation. Mm-hmm. We're also a participant in carbon capture and sequestration. In fact, we announced a year or so ago a relationship with Oxy in Houston with their 1.5 division, where we're working with Oxy on cloud technologies for CCUS, as well as an off-taker of carbon credits from their direct air capture facility. And I guess finally, probably good to mention on kind of the longer-term time horizon, in October of this past year, we announced an investment also with the Climate Pledge Fund in a company called X-Energy, which is a small modular reactor nuclear power developer. Again, longer-term time horizon, but our ambition with X-Energy is to deploy 5 gigawatts of power by 2039. So kind of looking ahead to our power needs as we continue to grow.
Right. So Amazon numbers appear on many of my charts, which sort of along that spectrum. Yeah. So and we'll come back to the sort of how that gets managed later on. But Jennifer, same question, that which are the key technologies you're involved in, and how are they going?
Thank you, thank you. And I'll just follow up on what Jeff had initially ended with, is with nuclear, with AECOM, we are working with our clients to really look at how do we take the fission capabilities into fusion, and what is that long-term investment. Like Jeff said, that's 2040. And so in more of the short-term, near-term, and we've heard about, and we all know the demands are continuing to grow. And so we are seeing quite a significant investment in LNG, just as that transition, and there were a lot of discussions about that yesterday. As you noted, solar, offshore wind is a little bit more volatile right now.
Yes.
And definitely with, and I think we'll cover this in a different question, but some of the policy changes. But so with AECOM, we're a global company that supports our clients, Amazon, and a number of you also out in the audience, and looking at those trends and where they go from US to Europe to China, as you've indicated, and then Latin America. We are seeing some tremendous interest in investment in the renewables, hydrogen especially, but then the grid. That is where we have really seen tremendous investment and growth needs, along with battery storage, in carbon sequestration. Battery storage, as that technology continues to develop, we'll see even more investment, I think, in the renewables and ability to have microgrids and solutions that aren't as dependent as our transmission lines.
Great. So again, quite a wide range. We're starting to see a sort of fairly consistent list of all of these different technologies in various stages. Jennifer, LanzaTech, what are you focused on?
We focus on carbon capture and reuse. We focus on the circular economy. We take waste carbon emissions and we convert them to sustainable aviation fuel and also materials. And I can't bring sustainable aviation fuel in this room, but I can bring this. I can show you that I'm wearing my Athleta shirt, which is made from recycled emissions. I can bring my Craghoppers jacket. I can bring my On hat. All of this polyester is made from a steel mill gas that was fermented into ethanol and then converted to polyester. So instead of emissions, and by carbon emissions, we're not just talking about CO2. Remember that when you combust carbon, you also get particulate emissions. So there is more than just a reduction in CO2. And so what we're doing is we take these either industrial gases, like at a steel mill, or we take gasified solids, like municipal solid waste. We have a bacteria that ferments them, converts them to ethanol. The ethanol can go to SAF. The ethanol can go to materials. Why does this matter? We talk a lot about energy efficiency. You spent quite a bit of time talking about that. But what we don't talk enough about is materials and carbon efficiency. And conservation of carbon is, to be honest, what energy efficiency is, because right now most of our power or fuels comes from carbon. This is not science fiction. Obviously, I've shown you products. We have 6 commercial facilities running, making products. And the one thing I want you to think about is why biology? I'm a thermochem girl, which means biology makes me nervous. But the reality is that if we transition to a future where more carbon is used to make the products we use every day, you are not going to be able to take waste carbon to a central location. We do that with petroleum, we do that with gas, because they can be concentrated, liquefied, and taken somewhere. You're not going to do that with trash. So what you have to do is take the technology there. And if you take the technology there, you need selectivity. You can't go from 1 unit operation to 5 to another 10. And so selectivity is king. And so the ability to make chemicals selectively is where the waste to products future is. So I'll leave it at that, and we'll pass it back.
And how are you finding that message goes down? How easy is people to understand that or get on board with it?
It's actually quite difficult for two reasons. One is carbon and material circularity is a newer concept. People weren't talking about that. But the other reason is because the way we do it is gas fermentation. And people are used to sugar fermentation, but a continuous process that is biologically based, that looks like a refinery unit operation, just kind of blows everybody away. And so then they just aren't sure. They want to ask you why it doesn't work rather than say, oh, okay, check the box.
Yeah, more challenging to understand. So great. And Tayba, at ADNOC, sort of where are you investing? And what do you see as the critical technologies for these sustainable solutions?
Before answering your question, good morning, everyone, and allow me to thank Baker Hughes and Lorenzo for inviting us to participate in this great event in the beautiful city of Florence. I believe everybody knows that the energy demand is really growing, and we keep talking about this even in the opening remark by Lorenzo yesterday. And this growing came actually from the increase in the population in the world, the increase in the technology demand, as well as the increase in the rising of the life standards. And the fact that population nearly equivalent to the size of Europe has no access to the energy as we speak. So as industry leaders, we need to act, we need to respond to provide more sustainable energy. At the same time, make sure that our progress on the net zero is on track. We cannot do it alone. We need all the sectors or the collaboration from all the sectors, technology developers, AI solution developers. We need more of partnerships, really, to progress in the net zero target. And I strongly believe technology will play a great role in to provide more sustainable energy, at the same time to decarbonize our production today. So going back to your question, in ADNOC today we are very proud about the progress we are making in the decarbonization. We are one of the lowest carbon intensity producer in the world, if not the lowest today. And we deliver this with a great partnership with a lot of partners, and Baker Hughes was one of them. Look at 50 years ago in ADNOC, we keep providing the energy the world needs, and we will continue to do that. We are investing in two main areas. First area, we are investing today in building the new energy system for tomorrow. We are allocating 23 billion to decarbonize our operation, to implement climate technology, and looking at greener solutions. And also this investment of 23 billion includes the increase in the capacity in the renewable energies. And the second area that we are investing in decarbonization, the current energy system, looking at electrification. For example, the company that I'm leading, ADNOC Offshore, we are investing 3.8 billion to decarbonize our operation from a mega project called Project Lightning, where we are going to import the power from the green source to operate our operation, offshore operation. And guess what? This will help us to reduce our emissions by 50% when this project will be in operation next year in 2026. On top of that, we are also investing in carbon capture. So really, we are doing a great progress. Now, on top of that, AI now is in the picture. And we know that AI will play a great role in our industry to help us to continue provide the green or the more sustainable energy. And to put in this on more content, that only in 2023, with partnerships like AIQ, Baker, and others, we deployed around 30 AI solutions and tools, generated $500 million in value creation in our operations in ADNOC. And this is only in 2023, where we believe that we're just scratching the surface. So to your question, where we are investing, it is from rock to stock among our value chain. And we are looking at what the customer needs, and we are looking at how we can provide the sustainable energy for future. Thank you.
Right. So it's from your customers all the way back through the whole value chain to your company and suppliers, et cetera. So very impressive. Thank you very much for that. I just wanted to change tack a little bit and talk a bit about policy and ask a question. Jennifer, I'm going to ask you about, particularly for these early stage technologies, what should policymakers be doing? What policies work, and where should they be focused?
Thank you, John. We've learned from the past as far as what investment has worked and hasn't worked from a policy standpoint, and whether it's tax credits or it's rebates or what that may be. I think the real focus needs to be a certain future, and making sure that it is, we are developing a sustainable market, right? And it's not just subsidies.
Right.
And one of the things, and you touched on this with the IRA, where there was such an investment, and we last year, we met with bankers last week in London, and there's such uncertainty in the U.S. right now that they're pulling their money and looking for those green funds and those green opportunities to invest in. They just can't find them because we need to make sure that there's policy that allows for a true market where there is the sustainability and the off-takers, so there's the incentive to actually purchase and drive that market. I think we've heard a lot of conversations about collaboration and what that really needs to look like, and it's driving that policy and the regulations. And we touched on this a little bit yesterday too, as far as making project implementation easier, and really looking at like the permitting process, not just in the US, but in Europe also, so that we can get speed to market, because that's what our clients, and I'm sure all of you are feeling too, it's how fast can we get to market so that we can start to realize that profit and really drive the margin.
Right, but it's not just sort of piecemeal, it's a sort of joined up
exactly
ecosystem.
Right.
That's because what we're seeing a lot with these early stage markets is the supply side's good, but the demand side's not, or the demand side's clear, but the supply side's not. So it's sort of balancing that sort of joined up policy thinking seems to be what you're...
And we see that in Europe, especially around hydrogen, where each country has a little different take. And so for a producer of hydrogen or an off-taker, trying to understand, well, where is the value and what does that look like from country to country, knowing that clients are buying regardless of where it's produced.
Right. Great, thank you. And Jennifer, I'm going to, same question around policymakers. You're involved in some very sort of early stage innovative technology.
Well, I think one of the most important things that policymakers need to do is be completely technology neutral. We need to be outcome-based and not how-based, not route-based. So in the United States, the renewable fuel standard requires a biological feedstock to get the tax credits. we're not a biological feedstock. We used waste, municipal solid waste. We use fossil waste that's being recycled. And so we don't qualify. Low carbon fuel standard in California is technology neutral. As long as you reduce carbon intensity, there's a path. So I think one of the biggest problems with legislation, it always favors incumbents if it's overly defined. And so it's really important to be technology neutral. So that's the first thing that I think is important. The second thing that I think is important with policy is to be level-headed and measured. We like to fall in love with ideas. We like to fall in love with unicorns that fly through the sky. But the reality is there are no unicorns. And we have to bet on the horses we have. And what we have to do is just take one step and then another, because it's those steps that allow us to de-risk new ideas and technologies so that we can actually get to the end game. So I think that's the second thing that's important with policy. And then the third thing that's important is, and we see this more and more with the Innovation Fund and the IRA, not just to bet on new ideas. New technologies need to first get to scale, the first valley of death, and then they need to get through the second valley of death. I call that the Grand Canyon of death. And that is creating a profitable enterprise. And both of those are very, very difficult. And both policy and government funding, if it doesn't just focus on the cute early ideas, but instead makes even-handed bets across the supply chain, will be beneficial.
How much do you think policymakers need to understand what the solutions are that they're creating policies for, if you like?
They do need to understand what the solutions are, but more importantly, they need to understand what they want to accomplish.
Okay.
Because the solutions, if you just focus on solutions, you will exclude something that you and I can't imagine today. What we do, gas fermentation, if you'd asked people 25 years ago, they would have said, you will never scale that, that will never work. And so it never got into policy. So you shouldn't define a route or an approach.
Okay, so it's being clear about where the end result you want to get to, and then supporting many different routes to get there. Okay, fantastic. Okay, great. I'm going to shift a little bit back now. Just onto the sort of technology management side of it, particularly around AI, because I know that's last year's hot topic. Let's see how it goes this year, but anyway, so far it is. And Tayba, you already talked about AI. So the question really is about the biggest challenges in accelerating AI adoption. What in your experience, given you, I think you said you have 30 different projects in 2023 alone, which is pretty impressive. So what have been the biggest challenges in the adoption of that technology?
I strongly believe that AI changed the pace of change itself. And things really are changing in a faster way than ever we experienced ever before. And for any company, it is really challenging to look at the best solution, which really bring more value to any companies. So yes, there is a huge challenge. At the same time, there is a great opportunities in that challenge. So maybe I will highlight three most challenges that I'm facing today. First of all, products. Every day we have new products in the market. So the challenge here, how fast we can really screen those products and to choose whatever applicable, which will add more value, more efficiency to our company. Second is the partnerships. How we can bring the energy experience or experts with the AI experts to develop the right solutions that any company needs. How we can bring this knowledge of, for instance, reservoir engineering, petroleum engineering, drillers, how we can bring those thoughts together with the AI who will build algorithm, coding, etc., for maximizing the value. And the most important challenge really is the people. If we ask ourselves today, is the people really know the value of the AI and how they can use AI to do their job easier, better, with less error, less risk? I believe we have a responsibility really to educate our people about the value of implementing the AI. In ADNOC, for instance, we already started that, and let me read this for you. In 2024, 40,000 employees in ADNOC completed the AI training. 5,000 will be trained in the prompt engineering, and 600 are on their way to being the next-gen AI experts. So we are really investing in our people in ADNOC, but I believe that we really need to upskill their skills, to educate them that AI will really help them to do their work in a more efficient way.
Great. So, well, it sounds 40,000 people being trained. That's very impressive. It must have been a very large training program. So great. Jeff, I'm going to come back to you in terms of AI was just one of the things you mentioned, but you touched on nuclear and hydrogen and CCS, et cetera. So it's really a question about how do you manage all of those different technologies, particularly internally? How do you get people to understand the dynamics and the risks you're taking and those kinds of things?
Well, at Amazon, I would say we have a culture that really thrives on experimentation, right? So, we kind of think of it as a fail fast kind of a mentality, right? So we'll evaluate certain technologies. We, of course, look very closely at the business case, the business benefits of the investments that we make in technology. But we view ourselves as very agile, right? So we'll spin up an experiment. If that experiment then works, we then are able to replicate that, more broadly at scale across our organization. In the event that it doesn't, we can tap the brakes and look for other alternatives. I'm super impressed by the results that you've described, the number of people that you've trained, the 500 million in results that you've generated just recently from the AI investments. That's an area that obviously we focus quite a bit on as well. And I really appreciated the comments you made about the connectivity between AI and decarbonization, because we really do see a strong linkage between the ability to apply AI in practice and the ability to optimize the design of assets, the operation of assets, right, in a way that helps to not only lower the cost of operation and improve safety, but also reduce the carbon footprint at the same time.
If I want to build on his comments about how AI really helping in decarbonization, I just want to give you an example of a technology we implemented in collaboration with AIQ that's called RoboWell. This is algorithm and a tool where we install it on the wellhead, and now we can monitor the well from the control room. Yeah. So in offshore, there is no need to send people offshore, and this is for sure will reduce the traveling time, logistic, emissions, and others. This is just a small example of what we are doing today, really to utilize AI to reduce the emissions and decarbonize the operation.
Yeah, just tagging off of something that, the things that you described a moment ago, I might add, you had a comment in there about kind of the human aspect and the training and the skills development. I'd say there's also another dimension of the human aspect, which is, once you've used AI and you've generated some insight from AI, ultimately that has to manifest itself in terms of action, right? So there's a change management process, I think, with respect to, business practices, work processes in the field to take, the insights that are derived from AI and applied out, at the coalface, in the assets themselves. I think the second thing that I might add is data, and how critical data is to enabling AI infrastructure. That's an area that we focus intensely on, making sure that in the example maybe that even you just provided, right, the ability to gather data in real time from an asset is key in order to be able to determine, its operating condition, its potential failure modes, and what therefore needs to be done in order to respond, out in the field. It's reminiscent of some things that actually that AWS and Baker Hughes are partnering on in terms of the work that we're doing together with Lucipa to try to optimize the way oil fields are being operated.
It's the first time in many years I've heard the term digital transformation. Having gone through the whole dot-com boom back in the day, digital transformation could solve everything. How different do you think this digital transformation is from the last one, from the one at the turn of the century? Jeff, what do you think?
It's always hard to define what digital transformation means, right? I think of it less about digital transformation and more about business transformation. Digital and technology is simply the enabler, right? I mean, I think when you talk about the dot-com boom, there was one set of technologies. The internet was new at that time, and that enabled a certain set of business processes to be changed and transformed. And I think what we're now seeing with AI and in particular generative AI, I mean, that's obviously the hot topic of the last year or so. It's technology that's providing a new set of capabilities that help us to accelerate, automate, new business processes, right? So for me, it's less about the digital transformation, and it's more about the business outcomes that you can generate and achieve by the application of technology in the business itself.
Right, and then yes.
I was just going to say, looking at it from an energy perspective, we talk about all the data centers and AI that need to have such a high energy demand. And I don't discount that, but looking backwards to see the future, right? When computers very first started, they were the size of this room, right? And they were the cards, and now our smartphones have that 10x, maybe 20x, the computing capabilities. And, we saw that with the disruption with, DeepSeek, as far as, I think from an energy perspective with AI and generative AI, I think that energy demand is going to decrease as technologies continue to evolve and we all get smarter, right? And so to Jeff's point, it is about the business case, and it's about understanding what that progress will take us and training our folks to think that way, right? So it's that whole change management, but from an energy perspective, and I know it's 28% more increased energy demand by 2028, or there's lots of numbers. But I think that's going to levelize a bit too.
Right. There are lots of numbers, and we actually haven't done the analysis on that.
I know
to take
you
a
have.
view
I
because
know.
we think it's too early, so
yes.
We don't want to straight line it because it's too scary, and we believe lots of these innovations will come along as they've proven and really bring down the power demand. So we're, we'll come out with something that I feel is more reasonable. Jennifer, last word. AI. How does that come into your world?
Well, actually, it's interesting because we've been using AI since before AI was sexy, because we sorry. Or maybe it was sexy a long time ago when I was young and we called it neural networks, but let's not go there. The reality is that we genetically modify our organism. So we design the carbon flow to make new chemicals. And to do that, you have to use AI. You have to use predictive modeling. You first define what the genome looks like, and then you predict the pathways which will optimize the product you make. That is the hardest part of what we do. But we also, and as you know, training a model is all about the data. And we have data from the lab to the pilot, to the demo, to commercial. And we use that to allow us to control our processes in the field. And while we don't fully control them now, biology is a little bit more chaotic sometimes than you want it to be. And so the ability to predict what you do to make sure your yields are always optimized is what we're using all our data for. So both at the very small level, genetic modification, all the way to process control of what we imagine as distributed factories producing the chemicals we want. We use it across the entire work that we do.
Great. Okay, well, thank you very much. We're going to leave it there. We're pretty much out of time. Please join me in thanking the panel for sharing their expertise. Thank you very much.